Hey, welcome to another Beltour Tech video. Since this is a ham related video, I'm putting my call sign up. Victor United 3 Golf Whiskey November. So I'm talking today about making infrared antenna, typically of the 49:1 type. So I'll be showing the process on how to build one infrared antenna, what are the materials required, and the general process, and where to get the material in India, especially around the Bangalore area or South India. Right? Okay, let's get started. So this antenna, it's 49:1 because it's 50 ohms into 49, 2450 ohms is the radial resistance, and that's what we are trying to build here. It's a transformer, it's got a primary, it's got a secondary. So why am I interested in this? Why am I making a video on this? One is, I have personally, I have a homebrew inverted V dipole having four bands, 40, 20, 15, and 10, and each of those have their own radials, right? So dipoles are very difficult to put up. You need to have space, and multiple bands means multiple radials, and you have to tune all of the radials together for them to work together, and switching your antenna tuner, it's get difficult pretty quickly. Whereas an end fed, you have one radial, typically 49:1 for a 40 meter to 10 meter antenna. You just need about approx 20 meters wire. It can be a electrical wire, common 2.5 square mm, which can provide you up to 200 watts of power that you can push through. Or if it is QRP, even a 0.75 mm wire is enough for you to push through about 20 whiskey, right? So when we did, we as in VU3 Tango Bravo Uniform, Rajesh was being the main inspiration for us experimentation. We got pulled into that, and along with VU3 UZD Sham and VU3 CIQ, and me, VU3 Golf Whiskey November, Guru Prasad, we have done a lot of experimentation around this, and kind of nailed down what needs to be done, how to do it, what not to do, what works, what doesn't work. So I'm trying to put all our experience so that it will help other hams in general. So why do we need to make this? Because it's an easy antenna compared to dipole to install, to manage, and the best part is it's tuned across all the bands. So recently when we went out for field day, I used the antenna that you're seeing here in the background. It's an open-ended and open antenna, not in a closed box kind of a thing, in a field day, and there is no heating problems, core heating problems, and I did not even use an antenna tuner when I used this with my ICOM 7300, right? It doesn't need an antenna tuner for most of the bands, 40, 40, 20, 17, 21, 12, and 10. It works, right? So that's the simplicity of this antenna. You just have to wind the wire along the toroid in a specific fashion, and it will work unless the wire is broken or there's something wrong with the toroid. It should work. Okay. So this infrared antenna, you build it carefully, will serve for many years, up to 200 watts on SSB for a single core and 58 watts on FT8, while double or three cores will increase that to 1 kilowatt and 200 watts on FT8. So right now today I'll just show you how to build one with a single core, but you can add multiple cores, and like what I've done in the image that you're seeing here. I've added two cores here and then wound electrical tape and then wound the wire. That electrical tape is just to keep the cores in place. That's all, nothing more than that. Some people also use glue to stick the two cores together. I don't want it because tomorrow I might take it out and use for two different antennas. So just put some electrical tape and it will hold good for years together. So heart of the engineering of this design is 49:1 impedance matching transformer, or ANAN, connects an unbalanced feed line to an unbalanced radiating element, where much of this DIY is focused. The approx 20 meter half wave radiating, I'm saying approx 20 meter is, once you put up the antenna, you need to tune it a little bit with a nano VNA or a SWR meter, just to ensure wherever you're putting the radiating element is tuned so that you get good SWR across all the major bands. When I say major band, I'm not generally talking about 30, 17, or 12 meters. So major bands are 40, 20, 15, and 10. Right. So yeah, thanks to fellow old man VU3 TBU, UZD, and CIQ for inspiration to continue experimenting. Right. So what does this look like? Right. 49:1 transformer. We call it a transformer because it's got a primary and the secondary coil. right? So the toroid that we are using is 240-43, which is 240 and 43 is the type toroid material type, right? So we take you can do it. Some people do it even with 1 square mm or 2 square mm electrical wire as well. Usually Teflon coated wires, it'll work, but I prefer using a copper enameled wire, enameled copper wire, right? So we have a two-turn primary, twisted turn primary, and one of that will come into the TX immediately after two turns, and you put a 100 picofarad ceramic capacitor across the TX on the ground. You don't need this if you want a transformer operating predominantly on the lower bands like 80, 40, and 20, but you will need it if you go to higher bands like especially 20, 15, and 10, right? So this capacitor does work, and I'll show you where to buy it and how much approximately it will cost. So you have the primary, one part of the primary coming to TX, the other one goes through the toroid. So the third loop, the fourth, fifth, sixth, seventh, and then the eighth one here, it comes off the top and goes into the bottom and comes out here. The turnaround like this is the eighth round, and then the ninth, the 10th, 11th, 12th, 13th, 14th, and out it goes to the radiating element. So this one is the eighth, and it goes to the radiating elements, right? So this is a simple way. Some people, I'll show you for other types of transformers that we have done a straight no crossover winding also, that also works, but this is the predominantly most famous winding type, so we'll focus on that on this method in this video. I'll make other videos for different types of transformers later on. So this is some of the various configurations we can do the primary transformer winding. Common high ratio transformer, 14 turns will give you 49:1, whereas 16 turns will give you 64. Some people do 15 for 56:1 as well. So the most beneficial or the most widely used transformer winding is 49:1, because it covers a wide range of users in a generic use like us. It's not very specialized, so generic, it works great across most of the majority bands like I mentioned earlier. So if you want, you can experiment with 16 turns. So 2 turns primary and then 14 turns secondary is what we are looking at here to derive a 49:1. You can add additional looping for 64:1. So this is a auto single tap transformer. So what will happen is you will not have two wires here. You'll have only one wire going, and then you will tap out for TX here after 2 turns. So I don't want to build this because when you tap out, you need to scratch out the element and then put one more solder there. So I would say it's a weak point because of the high temperature, the solder might come out, or if it is not soldered correctly, so it might cause problems. So here what we do is we just have 2 turns and one wire will come into TX, the other one will continue in the same loop, right? So that's much better. And this is plain different types of configurations for the same toroid winding for the transformer. So, and we talked about type 43, the ferrite type, right? So there are other types as well. Like I said, 240 is the size of the diameter and 43 is the material type. There is type 31, which I want to experiment with. If I get a chance, I'll buy one. I've not seen that many, but if I get a chance, I'll buy one. It's very good for 1 to 300 megahertz, covering both HF, VHF, and UHF as well. Type 43 is the most generically used, most popular one, 25 to 200 megahertz. But it does work from 80 to 200 as well, which I've seen it working. So not sure why they have mentioned 25 here. Anyways, type 52 is 200 to 1000, 61 is 200 to 2000. Type 75 is 1 to 10 megahertz. I'm just listing it out here so that you know what different core types are available in the market, or there are there in the market. Whether you can source it or not, different issue. So let's look at this one. I've taken from HF Sketch build instruction for impedance, and that's the source. So 10 to 20 meter, if you have got a 1:49 transformer, you need for just to 10 to 20 meter band, you need approximately 10 meters of radial. So this is the transformer and this is the radial you have. For 10, 20, and 40 meter with coil, you need a coil of 35 mu coil. So that is 10.1 meter up to the coil, and then 1.85 meter from the coil, right? So to build this coil, right, you wind on a 19 mm PVC pipe you take a 0.75 mm winding wire and then wind it for 80 windings. You probably need a inductance meter to ensure that you are getting around 35 microhenry value. Inductance meter may not be available with everyone, but you can generally wind on a 19 mm PVC pipe with 0.75. You should get about 35 microhenry if you stick to the specs. Then you have the 10, 15, 20, and 40 meter band, the most popular one. Like I mentioned, you have a transformer and then plus or 20 meter wire. You need to customize it based on your location where you're putting it. Reduce it by a meter, increase it by a meter, whatever, right? You need to tune that, but once it is tuned, it will work across all the bands. Then you have 10, 15, 20, 40. So similar to this configuration, you need a 110 microhenry coil. To get a 110, you can make 160 windings with 0.5 mm winding wire. So that should give you, there is no rocket science here. You wind it, you connect one part to the 20.5 meter wire, another part to 2.5 meter wire, and you should get all this. So based on my discussions with my fellow old man, is that in city conditions, if you add a 80-meter coil, it will pick up noise. So unless you specifically want 80 meter, I suggest stick to the third configuration that you have here, which is the most popular configuration. The interesting thing is, if you go with, I've worked with some people who have got just 10 and 20 meter. We just added another 10 meter wire to this, soldered it, and it'll work for 10, 20, 15, and 40 meter. Excellent. There is no issue. So, this is one thing I love about infrared transformers, is that you can configure your radials even after you build it. You don't want to work 40 meters, you just want to work the higher meters, chop it off by half and you'll get that wire. You change your mind, attach it back, and you'll go back to 40 meters, right? So it's very, very flexible. It's not like you're doing it once, you can do it again and again and again. So I usually keep multiple bundles of 10 meter wire, 20 meter wire, so with the lug nut attached, so I can just screw it whatever wire that I want and band I'm working, right? So if you are predominantly working, so like I do, you can keep a 20 meter wire to work on 40 and other bands. But if you have a 10 meter wire, you can remove that and add the 10 meter wire if you want to work only on 20 to 10 meters, 20, 17, 15, 12, and 10. And then it should work across all those bands with just a 10 meter wire. And you will end up, the lesser the radial, the less noise you will pick up. So that's the idea that you need to have, right? So what are the materials required? Let's look at that quickly. So as I mentioned, I'll show you how to build with a 1 toroid in this video, but you can add 1 or 2 toroids. Like I said, if you have 2 or even 3, right, wipe it, wrap it with electrical tape and it will stay put, right? So it's up to you. I'll show it with 1 toroid. You can do it with 2. About 1.5 meters of fairly thick string. I'll tell you in the video that will follow why do you need this thick string. Then about 1.5 meters of 16 or 18 SWG enamel copper wire. Keep it 2 meters, then we can chop it off, for the winding, depending on how many toroids you have, right? More toroids, you need more wire. 5 to 8 mm thick acrylic sheet. This for field day usage. I'll show it with acrylic sheet and I'll show you some of the boxes I've made. It's up to you whether you want to put it in a box or not. But in this video, we'll focus only on the acrylic sheet part. Then IP65 rated plastic box for a permanent setup. Then 1 into M5 eye bolt just to hang it up or hold it. 5 mm SS bolt, 5 mm SS nut, 2 each. 240 ohms resistor or a pot, 3K pot, so that you can bring it down to 2450. Usually don't get 2450 ohms, you'll get 1.1K, then you need to add 1.1K, 1.1K, 2.2K, then add another 250 ohms to get to it, right? So then you need 100 picofarad 15 kilowatt ceramic capacitors, then 5 mm wing nuts, to place the lugs wire elements and then twist it off. Then SO239 UHF female socket. If you are doing QRP, even a BNC female is enough. Otherwise, go with SO239 if you plan to make it for more than 100 watts. BNC will support up to 100 watts, but I just stick to SO239. Then M3 bolt and nuts. This is to fix the SO239 onto the cabinet or the acrylic sheet. I've mentioned 4. You can do it with 2 if you have got a good set. Again, M3. Make sure it is SS so that it will work for a long time. Then 6 inches of 2.2 mm, just to ensure you'll have to connect the negative of the counterpoise thing to the 239 chassis, the grounding. So for that, since it is plastic, right, so we need to do that. Or you can attach that counterpoise thing to the M3 bolt that you are screwing into 239. That will also work. 20 meters of 2.5 square mm for radials, then 5 lug nuts, 5 mm size lugs for the wires, the primary wire that will go in for the TX will anyway solder to the center pin of SO239, but for the grounding, for the counterpoise, and for the final radial wire that will go into the screw, the 5 mm screw. So you need a lug and put it to the screw. Then some 5 mm washers, soldering kit, multimeter, VNA not necessary, but it will be helpful if you have one to check the SWR. If you have done the winding correctly, you don't need a VNA. Just add in a radial and it should work. Very confident on that. Then okay, where do source in Bangalore? I'm restricting myself to Bangalore, but most of it can be shipped to your location. So 24043, contact VU3 CER, Dhiru, or VU2 ELD Chris. They should be able to supply it. Last I checked, it's about 1,500 for two, approximate range. So don't hold me on the prices of anything. I'm just putting my experience here of where I've sourced all the material. So I'm just putting it here for your benefit. About 1.5 meters. You'll need more than that. Approximately, when you go to in SP Road, when you go to buy the copper enameled wire, buy. I forgot to mention here. Buy some heat shrink also. 5 mm, 6 mm heat shrink, about a meter two. You'll need it somewhere down the line. So they charge about 150 or 200 for 300 grams of wire. That is more than enough. 16 or 18 SWG. Again, don't hold me on the prices. It might change. IP rated box, I've put in the URL there. You can talk to them. They are in Batranpura near Mysore Road. So you can go pick it up from there. M5 I bolt. I had to source it from eBay. But again, no customs and approximately 600 rupees shipped for 5 or 6 of them. More than enough. It will take about 20 days. We searched in Bangalore. We did not get this very good quality M5 bolt, so we had to get it from eBay. Then you need all the bolts and nuts, the washers, everything, even the wing nuts and everything. I've given the address of these guys. Approximately 400, because they don't give 1 or 2 items. You'll have to buy a dozen at least, and preferably go to them on early mornings when they open up at 10:30 on weekdays. Don't go on Saturdays. They are super busy on Saturdays and they won't uh, cater to small purchases. So go to them on weekdays, Wednesday, Thursdays types, when they're not very busy, and early in the morning they are more receptive, is my experience. Then ohms resistor or 3K pot, 40 rupees from Universal Electronics SP Road. They're in a side lane, away from all the major electronics, Vishal and all. They are away from that, probably fourth or fifth road on the left side from Vishal. So nice guys. They've been there in SP Road for a long time and they'll help you out. 100 picofarad 15, approximately 200 for 5. I bought it from U to MUD. I don't know why it's not coming here. I've added his name. Okay. Anyway, so then SO239. This one, ceramic capacitors, is also available on eBay. I'll fix this PPT. It might have pushed down on eBay. I've put the link also, or you can contact me to MUD. We should also be able to provide you this. SO239, either Windsor Waves, Electronic City. I've given the number here, or Electrophase Connectors, SP Road. They are also, it's available, about 200 per unit, approx, right? Don't hold me on the prices. Copper wires, 2.5 electrical wires, standard electrical wire, all this fancy fire flame resistant, anything is fine, right? So cable craft, opposite Vishal Electronics. Soldering kit, multimeter, Vishal Electronics, standard place to go. VNA, if you want, you can source it on eBay or Telegram groups. It will cost you anywhere between 6 to 8K. So I don't recommend it. If you have it, good. Otherwise, you can borrow it from someone, right? So these are some of the completed examples of my own work. Also, my team has shared some photos. So this is with a 43 type material, but a more denser core. We have used a Teflon wire to wind this. Again, you'll see the capacitor here, the antenna radial wing nut here, and the SO239 bottom here. So this is another transformer I've done with enameled wire, which is what we'll do today. Even though here it is 2 core, I'll be showing you 1 core, right? And this is my field day antenna that I've done. This is 8 acrylic sheet, and this one. So this is how it looks when it is on the air, or rather tied to a tree and then with a rope. Yeah. Okay. Thank you very much.